Good morning, ladies and gentlemen. Okay, we have talked about right triangle trigonometry, which right triangle trigonometry, every time I talk about it, I just say SOHCAHTOA, because that helps us remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse and tangent is opposite over adjacent. So that's called right triangle trigonometry. Secondly, we have talked about the law of sines. That was a really easy formula where the sine of some angle is to the opposite side, like the sine of some other angle is to the opposite side, as long as they're in the same triangle. And then lastly, we talked about the law of cosines. Okay, and the law of cosines was a little bit more complicated, but it was where some side squared is equal to the other two sides squared minus 2 times those two sides times the cosine of the angle, and that was pretty complicated, a little bit uglier, but all together, it was all right. So here's the thing. Right triangle trigonometry, law of sines and law of cosines. That's what we've done. And this is all the trig that we're going to do. And so now what the plan is the plan is for you to get to work on several different types of problems for which you have to figure out which one of these systems are you going to use to solve it. And you might even use more than one system at a time. Maybe you're going to use a little bit of right triangle trigonometry and then law of sines. Maybe you're going to use law of cosines and then law of sines, or maybe you're just going to use one. That's fine. So what I'm going to do right now is I'm going to walk you through some problems. Now, these aren't going to be all of the types of problems we're going to see, because part of this is you learning how to use the tools that you have. I believe that with this group, you guys are great at these. The scores on the quizzes on these 3 sections were higher than any other scores and any other quizzes that we've had. And so you guys know this material. So let's show and let's really work through it. There's only one idea that kind of goes along with trigonometry that we have to discuss, but we'll get there in a second. First thing I want to do is talk about we can use all this trig to find the area of any triangle. And we got to remember what the area of any triangle is. The area of any triangle is always 1/2 base times height. That's the general formula that we want to keep coming back to and keep operating around. Okay? And so let's take a look at a problem here. So here's a triangle that I've got. Let's just kind of take stock of everything I have. I have 2 angles and I have 1 side. Now, everyone in this room should know if I have 2 angles, then finding the third angle is really simple at that point. The third angle, I just, go 52 plus 41 adds up to be 93. Subtract that from 180, and I get 87. And so I know that that one's 87. Now, what I want to do for this one right here is I want to remember that I can find x, I can find y, and I can find the area. We did all this on that law of sines quiz, but it's been a little bit, so I just want to kind of do a quick review. So for finding x, I'm going to start with this idea that the sine of 87 degrees has a relationship to 43 in the same way that the sine of 41 has with x. And then I cross multiply and get that x times the sine of 87 is equal to 43 times the sine of 41. And then I have to divide both sides by the sine of 87. And then that's what I have. So then I know that x is equal to that right there. So I go 43 times the sine of 41 divided by the sine of 87. And that gets me 28.24. So, if I go, well, that's about 28.2. And then to do y, you all know, this is just as easy. So I would start with the sine of 87 is to 43 in the same way. And this time I pick the angle opposite of y, which is 52, is to y. Cross multiply and solve, and if I kind of skip a step there, it's going to end up being y is equal to 43 times the sine of 52 divided by the sine of 87. And that's where I should get. So I go 43 times the sine of 52 divided by the sine of 87. Make sure you're closing the parentheses when you do this. And for that one, I get 33.9, about. Okay. So now the question is, well, how do we find area? Because that was something we did pretty quickly, and maybe not all of you feel real confident about that. So we think about area. Well, what do I need? We said we need base and we need height. And really, you can look at this triangle from different views. As I look at it right now, the base would be 43, okay? But the height is perpendicular to the base. So as it stands right now, I don't really know what the height would be. But when I say perpendicular, that should make us think, well, that's a right angle. And so in this case, I could kind of look at this triangle created right here, this right triangle. knowing that this side is the height, and that's the side I want. Well, that side is opposite of this 41 degrees, and y is the hypotenuse of that right triangle. Opposite and hypotenuse is sine. So I would know that the sine of 41 degrees is equal to opposite, that's that height, over hypotenuse, which is that y value. So then to get h all by itself, I'd multiply both sides by y, and I get that h is equal to y times the sine of 41 degrees. All right? And so now if I wanted to get the closest to the exact height, what I would do is I would actually take this value right here and plug it in for y, because that's what y is. You know, I could grab my calculator and say 43 times the sine of 52, close the parentheses, divided by the sine of 87, and hit enter, and that gives me that 33.93096, and then just hit times sine of 41, and hit enter, and that gives me 22.26. And so that's about what the height is equal to, but if I'm trying to find area, what would make sense is to plug it all in at one time. So right now in my calculator, I have something that is the height, and I got to multiply that by the base and by 1/2. So I say times 0.5 times, and my base is right here, 43. And so then I get an area, and so now I can round it. And it's about 479. It was 478.6, so I rounded up to 479. But remember, if I round the problem, you know, right here to get this y value, and then plug that into here and round that and get a value, and then plug that in, I'm going to keep getting further and further away from the right answer. So I want to round as little as possible. So my goal would be to not use these decimal approximations. Now, if that's crazy confusing for you, then use them. But really, you want to be as accurate as you can be. All right, now that you've seen me do one, I'd like you to do one. So we're going to pause the video right here, and I want you to find x, y, and the area of this triangle. Okay, hopefully you have it right now. I'm going to move through it real quickly because I think that you guys probably understand this real well. 54 plus 92 gives me 146. When I subtract that from 180, that leaves me with 34 degrees, I believe. Let's see, 3, 5, 8. Yep. Yeah. Okay, and so then what I'm going to do is I'm going to say that the sine of 92 degrees is to 23 in the same way that the sine of 34 degrees is to x. I'm going to go ahead and skip a step there so I can just kind of keep this moving. So I know that x is equal to 23 times the sine of 34 degrees over the sine of 92 degrees. 23 times the sine of 34 degrees divided by the sine of 92 degrees. Make sure you're closing the parentheses on those. And I get that x is about 12.869, so it would be about 12.9. Okay, let's go for y. For y, I'm going to start out the same way. Say sine of 92 is to 23 in the same way that the sine of 54 is to y. Cross multiply and solve. Again, I'm going to skip a couple steps, and I get 23 times the sine of 54 divided by the sine of 92. So therefore, y is about, so say 23 times the sine of 54 divided by the sine of 92. Okay, about 18.6. All right, so those give me those approximate values. But then I want to say, well, let's find that a value. Let's find the area. So I got to remember, I got to think perpendicular. This thing right here is the height. Now, I remember that the sine of 34 degrees, again, if I look at this triangle, I don't have to look at that triangle, but if I'm looking at that one, the sine of 34 degrees is equal to opposite, which is the height, over hypotenuse, which is y. So then, to solve, h would have to be equal to y times the sine of 34 degrees. Okay, so here's my y value, but the exact of that one is still in my calculator, the 18.6187329. And so I'm going to keep that in my calculator, but then go ahead and just hit this times sine 34. So I'm going to hit times sine 34. And now I've got 10.411463331. And so that is the closest thing I can get to height. So the area is equal to 1/2 base times height. I've got this in my calculator. So now I just need to multiply by that and that. So I'm going to say times 23, the base, times 0.5, the 1/2. Hit enter, and I get the area is approximately 119.7. Now that's the most accurate way to do it. Instead of using this approximate number, I'm using the most accurate as I can. Now, if I go back and try this approximate number of 18.6 and say, 1/2, 0.5 times height, or 1/2 times base, so I'm going to say times 23 times the height, which is going to be 18.6 times the sine of 34. Let's see how far off my answer is. And it's 19.6 instead of 19.7. So very close. Obviously an acceptable answer. Okay? All right, next one. This is not the same kind of situation. This is a law of cosine situation here, but I'm asking for all the same information. What I'd like to do is I want you to tell me what x is, what y is, what z is, and also what the area is. Okay, I think that everyone in here can do this, but right now, in case we need a quick refresher, this is a law of sine or law of cosine situation because I've got side, angle, side. All right, so if I was going to do this, the first thing I could go after is maybe z, figuring out the length of that side. And I'd know that z squared is equal to what? 29 squared plus 15 squared minus 2 times 29 times 15 times the cosine of 110. And this is one where I just get to plug the whole thing into my calculator and it becomes really simple. And I get that z squared is about 1363.55 something, and I got to square root that answer, and I get 36.9. But z is about 36.9. So that's what this is. So now I'd have all three sides, and so at this point I could figure out the angles. Okay, I could use law of sines, or I could use law of cosines to figure out the angles, and then I've got to think about finding that area. Okay, so first let's go after those angles. I want to go after the smallest one first, so that would be x, because opposite it is the smallest side. It's going to say sine of x is to 15, the same way that the sine of 110 is to 36.9. Okay, cross multiply, you're going to get that the sine of x is equal to 15 times the sine of 110 divided by 36.9, and this is the thing that you have to enter into the inverse sine. So I say inverse sine 15 times sine of 110, close the parentheses, divided by 36.9, close parentheses. And for this, I get that x is about the angle 22.456 degrees, so it's going to round down to about 22 degrees. So if x is 22 degrees, and this is 110, that gives me 132, subtract that, and y would have to be 48. So now I have all my answers except one. I don't have the area. I know that x is about 22 degrees. I know that y is about 48 degrees. I know that z is about 36.9. So how do I figure out area? Because this is one of those situations you can go, man, I don't maybe have what I need. Well, again, when you draw that right angle, it doesn't have to be inside the triangle. This z would still be the hypotenuse of this right triangle that I've now drawn. Okay, this angle would work well enough. And so I can use that and say, well, the sine of 22 degrees is equal to opposite, which is that height right here, over hypotenuse, which is z. So therefore, multiply both sides by z, and the height is equal to z times the sine of 22 degrees. Now, the thing I don't love here is that we're using an approximated number and an approximated angle. So that's going to keep throwing the answer a little bit further off every time. Area is equal to 1/2 base times height. Here's my base. So I say 0.5 times my base, 29 times the height, which is z, 36.9 times sine of 22. And for my area, I get 200.43. About 200.4. All right. Now, with that example, hopefully you guys can walk through all of it. Here's one for you. Exact same situation. We're going to pause the video right here, and I want you to try to solve this. Okay, since you've done this one, I'm going to walk through it really, really quickly. The very first thing we're going to do is we're going to do that law of cosine, saying z squared is equal to 13 squared plus 21 squared minus 2 times 13 times 21 times the cosine of 121. So 13 squared plus 21 squared minus 2 times 13 times 21 times the cosine of 121. And I get about 891, and when I take the square root of that, I get that z is about 29.85, which would round up to 29.9. Okay, so that's what this is, 29.9. And go ahead and do law of sines. I know the sine of 121 is to 29.9 in the same way that I'm going to go after the smaller one. Sine of y is to 13. Cross multiply and solve, and I get the sine of y is equal to 13 times the sine of 121 over 29.9. I got to put that into my inverse sine, 13 times the sine of 121 close the parentheses, divided by 29.9, close parentheses. Hit enter. I get about that y is about 21.88, so that's about 22 degrees, which is what we had last time. So 22 degrees. So 22 plus the 121 gives me 143, leaves me with 37 degrees for x. Okay, now we got to think area again. So I'm going to draw this part down and say that would create this right triangle. This part right here would be height. Okay, and so still that would be based off of this angle, and this is the hypotenuse. So I say, well, the sine of 22 degrees is equal to opposite, which is the height, over hypotenuse, which is z. And then in this case, z is about 29.9. So therefore, we multiply both sides by that z, and we get that the height is about 29.9 times the sine of 22 degrees. I know the area is equal to 1/2 base times height. So we say 0.5 times the base, 21, times the height, 29.9 times the sine of 22. And I get that the area is about 117.6. All right, hopefully you got the same thing. All right, so that's something you should be able to do. No matter what kind of triangle I give you, you should be able to find any and every part of it using law of sines, law of cosines, and maybe some right triangle trigonometry to find area. All right, well, here's the next thing. We need to talk about angles of elevation and depression. I've mentioned these in every class, but it's been something very quick and very briefly mentioned. So now I want to make sure you hear it completely. Okay, and it doesn't matter whether it's an angle of elevation or an angle of depression. They are always measured off an imaginary horizontal at any given point. Those red dashes are not lasers coming out of this guy's eye or this other person's eye, but that is just saying that there's an imaginary horizontal line at any given position. Okay, and so here we are in the situation. Here's some FCA student, and here's some NBA ball player. Okay, and so as the FCA student looks up, we can say maybe they look up with a 21-degree angle. Okay, well, where is that angle measured? It's measured between the line of sight and the imaginary horizontal at that point. This is where that angle is measured, that 21 degrees. Okay, so you would say that the person is looking up at an angle of elevation of 21 degrees. The most important thing that you can hear me say is that the angle of elevation is always measured off the horizontal. It's never measured off the vertical. Okay, it would never be measured all the way from here. As this person's looking down, it would never be measured from here. It's none of that. It's always measured off the horizontal, whether it's really there or whether you're drawing an imaginary horizontal. So now let's think about what angle this person's looking down at. That would be a depression. Looking up is elevation, looking down is depression. And so you go, okay, well, if this is a horizontal and this is a horizontal down here, then they're parallel lines. And this angle right here would be an alternate interior angle. So it's got to be 21 degrees as well. So it's kind of interesting, as you look up with a 21-degree angle of elevation, this person has got to look down at you with this same angle, but it's an angle of depression. So you look up above the horizontal, that's an angle of elevation. You look down below the horizontal, that's an angle of depression. But whatever angle you look up at would be the same angle that the other person is looking down at. Okay, and I hope that that makes sense. So now let's try some situations where we would have an angle of elevation. Okay, so here we go. Ready? In this situation, we're going to say that this person is about 6 feet tall, but to their eye level is about 5.5 feet. All right, and we're going to say that they are some 30 feet away from this flagpole. They're looking up with an angle of elevation of 37 degrees. And the question is, how tall is the flag? What is the height of the flagpole? Okay, now this has a couple different parts. We're dealing with angle of elevation. We know the distance away from the flag. We know how tall the person's eye level is. And we've got to use all three of those components, and we can then find the total height. All right, what I want to do is, this might be a really easy problem for you, or you might be a little overwhelmed, but I want everybody to try it for about 2 or 3 minutes, come up with an answer, and we'll compare it to what I've got. So we'll pause the video right here and see what you can do. Okay, let's talk about it. For this one, hopefully you see it, you go, man, this is easy. Okay, first of all, I just have to figure out how long this section of the flagpole is. Okay, and so I'm going to call that X. So I know in this case that not sine, but the tangent of 37 degrees is equal to opposite, which is that x, over adjacent, which would be the 30 feet. To get x by itself, I multiply both sides by 30, and I get that x is equal to 30 times the tangent of 37 degrees. All right? And so that is going to give me that x value. So I plug that into the calculator and say 30 times the tangent of 37 degrees, and I should get about 22.6. That's what this is about, 22.6. Okay, now is that my answer? No, because that's only this distance right here. And I have to add this distance, which is the 5.5. So then I take my 22.6 and I add my 5.5 and I get a total answer of 28.1. So someone says, how tall is that flagpole? You go, well, it's about 28.1 feet. Okay, 28.1 feet. And hopefully that's the same answer that you got. All right. Next, let's try another situation. We'll do a little rock climbing, okay? So here's the deal. There's this rock climbing surface, and we see someone climbing. I'll try to draw a little climber right here, all right? And we look up and see that climber, and we'll say the angle of elevation from the ground, we won't do it from eye level, the angle of elevation from the ground is 75 degrees, okay? And then they kind of keep climbing, and they get up to this point right here, this higher point. And we'll say that the angle of elevation from the ground at that point is 79 degrees. All right. Now we'll say we are some 75 feet away from the cliff face. And so my question is, not how high are they at the highest point, but how much did they climb to get from this lower point right here to this higher point right there? And you have enough information. This is actually a pretty simple problem, and there's a couple different ways to do it. But what I want you to try to do right now is go ahead and think of through the different methods, whether it be law of sines or right triangle trigonometry or law of cosines, and figure out how far did this person climb in the distance from the angle of elevation from 75 degrees to 79 degrees. So we're going to pause the video right here, take about 3, maybe 4 minutes, and you should have an answer. Okay, let's give it a shot. Okay, for this one, really, it comes down to basic right triangle trigonometry is, I think, the easiest way to go. I've got one right triangle right here, okay? And with this triangle, what I can do is I can find this distance right here. Now, that's not the distance I want, but I can find that distance. And then I've got another right triangle. It's this larger one right here, okay? And with that triangle, I can find this whole distance right here. And that's not the distance I want either. But if I subtract them, I will get this. Okay? So here's what I'm going to do. I'm going to look at first at that larger triangle. And we're going to pretend that this right here, that's got that 79 degree. And we know the bottom is 75. So I'm going to call this x. Well, to find x, I'm going to say that tangent of 79 degrees is equal to opposite over adjacent. So therefore, x, you got to multiply both sides by 75. You get x is equal to 75 times the tangent of 79 degrees. Okay, so I get that x is about 75 times the tangent of 79. It's about 385.84. About 385.84. Okay, now that's not the answer. That's the length of this blue line. Now I got to find the length of that red line right there. And so I say, okay, again, let's draw a little right triangle. Say this is 75 degrees, 75 at the bottom, and we'll call this y. Well, I know that the tangent of 75 degrees is equal to opposite y over adjacent, 75. Multiply both sides by 75, and I know I have a 75 degree angle and a 75 foot side, and that might be a little bit confusing, but we can get over that. So I say 75 times the tangent of 75. Hit enter, and I get 279.9. 279.9. What I have to do is subtract this number from this number. So I take my 385.84 minus 279.9, hit enter, and I get a final answer of a 105. That distance right there is equal to 105. Let's see here. Get rid of this. There we go. The answer is 105.94. So I'd be okay if you said, well, that answer is 105.9. Maybe you rounded up and said, man, over that time they climbed about 106 feet. Either way you go. So I know that I was able to figure out how far they climbed in that distance that changed the angle from 75 degrees to 79 degrees. All right, just a couple more. All right, here's the deal. What I want to do in this one is we're going to do it a little bit backwards from some of the things we have been doing. I'm going to say that this person right here is a younger person, and they are only 4 feet tall. However, their shadow is 7.5 feet long. Okay, so this person is 4 feet tall, but their shadow is 7.5 feet long. Well, I've given you all the information, so what could be the question? The question is, what is the angle of elevation to the sun? All right, you guys can do this. I know you can figure it out. So I'm going to give you 2, maybe 3 minutes to work on it right now, and then we'll talk through how to do it. Okay, hopefully you realize that with this situation, if I'm talking about this angle right here, this side is adjacent to that angle, this side is opposite. So opposite and adjacent always leads me to tangent. So I know the tangent of the angle I'm looking for is equal to opposite, which is 4 feet, over adjacent, which is 7.5. All right, now this is not one of those where I multiply both sides by 7.5 because what I want is not in the top right here. So instead, what I have to do is I'm going to think, wait, this x is what I'm trying to get by itself. So I've got to use the inverse tangent on both sides. Because when I do the inverse tangent of the left side, it undoes tangent, and it leaves me with x is equal to the inverse tangent of 4 over 7.5. And so then I get that x is about, and so I say inverse tangent, 4 divided by 7.5, close the parentheses, I hit enter, and I get almost exactly 28 degrees. So if this was a real situation, you had a 4-foot person walking around, their shadow was 7.5 feet long, you'd say, all right, there's an angle of elevation to the sun of 28 degrees. There you go. Okay, these are the type of problems that we're going to do. There's going to be some problems that are going to be easier than these and some problems that are going to be harder than these. Okay, but what I'm going to have you do is I'm going to have you work on some problems out of the book right now. Almost all of them give you a description of a situation. Most of them have an illustration to go along with it. But the whole point of what we're doing right now is we're trying to do application problems that you have to figure out what you need to do. Okay, so we're in your books on page 378. And what you're going to do is you're going to start at number 15. And you are going to work your way all the way to number 25. I'll tell you, number 25 is a little bit of a crazy problem. It actually gives you an extra piece of information. You got to figure out which one that is that you don't need whatsoever. Okay? But otherwise, these are going to be problems that you can do. All right? I will see you guys on Monday, realizing that we only have today, Monday, Wednesday, and Friday, and then we are done. Okay? So good luck.